we're going to derive the formula for the derivative of cotangent. And we'll actually do the proof, I guess, maybe twice. I suspect it's negative cosecant squared. Proof 1. The derivative of cotangent of x is the derivative of tangent of x to the negative 1. So the derivative of anything to the negative 1, well, you keep the anything the way it is. You bring down the power, you make the power 1 less, then you multiply by the derivative of what's in there. So we have negative. This is really going to be cotangent squared x times secant squared x. And that's actually a valid answer. I've never seen it look like that before. Here's the negative. Cotangent of x is cosine of x over sine x. But it's squared because we have cotangent squared. Times secant squared, well, that's 1 over cosine squared x. And this actually cancels out to 1. So we have negative 1 times 1, which is negative 1, over sine squared x, which is negative. And 1 over sine x is cosecant x, but we have sine squared x in the bottom. So we get negative cosecant squared x. Actually, I never proved it this way before. Now, proof number 2. The derivative of cotangent of x is the derivative of cosine x over sine x, which of course is a fraction. I'm going to use the fraction. The derivative of the top times the bottom minus the top times the derivative of the bottom all over the bottom square. So negative sine x times sine x is negative sine squared x minus cosine x times cosine x is cosine squared x all over sine squared x. In the top you can factor out a minus sign. So you have minus sine squared x plus cosine squared x all over sine squared x equals minus, now sine squared x plus cosine squared x is 1 over sine squared x, which is negative 1 over sine x times another 1 over sine x, negative. Now each of these are cosecant x's. And since it's twice, we get cosecant squared x. And here's the derivation 2 different ways.